All right, in this lesson, we are going to discuss proportional reasoning. We've been talking about ratios, the comparison of two quantities in the same unit, and rates, the comparison of two quantities in different units. And now what we can do with ratios and rates is if we make equivalent ratios or equivalent rates, we call this a proportion, right? So if we have like 3 kilometers per hour, and we say 6 kilometers per 2 hours, those are equivalent rates, and they are in proportion, right? If I double the numerator, I double the denominator. So by making two ratios or two rates equal, we have proportional reasoning. So what we're going to do is we're going to talk about proportional reasoning and how to solve questions using proportional reasoning with rates and ratios. And I'm going to give you a couple of options and ideas for solving them. So far we already have been solving them, so you already have ideas. And I'm just going to more of a recap today, plus introduce one more little idea to help you with more difficult proportions. So one way we can do it is we can use a unit rate. Make it out of 1, and then we can make it out of anything. For example, if it's 11.58 cents per 3 kilowatts, then we can find out how much it costs per 1 kilowatt. So 11.58 divided by 3 is 386 per 1 kilowatt. And now we can make it out of any number we want, right? So if we want to make it out of 18 kilowatts per hour, or sorry, 18 kilowatts, then, and this is still in cents, right? We still have our units following along with us. Now I'm multiplying by 18, so I take my numerator and I multiply by 18. And I get 69.48, which I'll round off to 69.5 cents. All right, so we could use a unit rate to calculate. The other way we can do it is using a proportion. Well, I know if I have 11.58 cents per 3 kilowatts, this is equal to how much money per 18 kilowatts? I just put an X or an N or a variable in the one piece of the proportion I do not know. And I can just use my proportion solving. I can say, well, how am I getting from 3 to 18? Oh, I'm multiplying by 6. Whatever I do to the numerator, I do to the denominator. So I take my 11.58 and multiply by 6, and I get the same answer. All right, so that is our two options. Now, true or false? If there are 60 milliliters of sugar in 600 milliliters of pop, then 1 liter of pop contains 100 milliliters. So we're going to set up our proportions and see if they are equivalent. Are they the same? So if I have 60 milliliters of sugar in 600 milliliters of pop, is this equivalent to 1 liter of pop, which is 1,000 milliliters? Does it contain 100 milliliters of sugar? So you have to make sure you match up your units. The sugar goes on top, the total pop goes on the bottom. And I can see that, are these equal? Well, what do I need to multiply by to get to 1,000? So 1,000 divided by 600 is 1.6 repeater. If I multiply that by 60, do I get to 100? Yes, I do. Those are equivalent. Or I could have reduced this. I could have reduced this down to 1 over 10 and then said, oh yeah, 1 over 10, and this reduces down to 1 over 10. Yes, those are equivalent. Okay, so we can test equivalency in proportions as well. A car needs 9.4 liters to go at 100 kilometers. So this is its fuel efficiency. It will need 56.4 liters to go 600 kilometers. Is this true or is it not true? Well, how am I getting from 100 to 600? Oh, that's simple. I'm just timesing by 6. So I take my 9.4, multiply by 6, and yes, it does end up being true as well. So we can make equivalent ratios or rates. if 15 oranges, so let's try both ways here. If 15 oranges cost $2.25, then how much would it cost to buy 20 oranges? Well, I always like to put money on the top. It's just that much easier. Whenever you see money, you go 15, $2.25 per 15 oranges. And we want to know how much does it cost per 1 orange. So we're going to take 2.25 divided by 15, and I get it's going to cost 15 cents per 1 orange. And now I can make it out of 20, right? So I multiply that by 20. And I get, oh, it's going to cost $3 for 20 oranges. The other way we could do it is we have $2.25 per 15 oranges, and we say, well, I want 20 oranges. What is the number? What is the cost? So how am I getting from 15 to 20? I'm not sure, so I go 20 divided by 15, and I get 1.3 repeater. This is the time I'm not a big fan of this, because you need to have, if you round off, you lose accuracy, right? So you want to get as many decimals as you can if it's a repeating decimal. So I take what's in my calculator and I multiply by 2.25, and I get $3. Okay, if you round it off and you went 1.3 multiplied by 2.25, I would get $2.93. You can see you'd be losing accuracy. So whenever you have to round off in a question, it's not my favorite method. If you get a nice, clean, terminating decimal place, it's a good method. If you're getting one that goes on forever and does not end or terminate, then we want to talk about, well, what's a better strategy? Okay, because sometimes both of them give that. So that's what we're going to talk about. How can we use our algebra skills to come up with these missing pieces in our proportion without having to round off? For example, how am I getting from 4 to 3? Well, I'm dividing by 1.3 repeater. Yet again, I'm getting a decimal. So remember, whenever you have a proportion equals a proportion or a fraction equals a fraction, we can use our algebra skills. Right here, x is being divided by 3, so I can multiply both sides by 3. Right? The 3's will cancel. Oh, 3 is being divided by 4, so I can multiply both sides by 4. Those 4's will cancel. Right? So you can divide by what's in there, in the bottom, right? Or multiply by what's in the bottom, and you can cancel them out. So really, I have 3 times 3 equals 4 times x. That's what I'm left with. And so what we've just showed you here is what's called cross multiplication. Where did the 4 times the x come from? Right? Well, if I look here, we have 4 multiplied by x, don't we? Or I can say, well, where did the 3 times 3 come from? Well, here I have 3 multiplied by the 3. So you can see why it's called cross multiplication. You take the diagonal of one, right, and make that equal to the product of the other diagonal. So now we have our 9 equals 4x. We divide both sides by 4, and we get x equals, 2 1/4. We don't have to work with repeating decimals, and we get a nice answer. Or we could have just taken our calculator and gone 9 divided by 4 and written 2.25, right? Either way. So let's practice this cross multiplication. So I typically always look for x first, wherever it is, and take what's diagonal, because I like my x's on the left. You don't have to do this, I just like to. So I take my 12 times x first, I write my equal sign, and then I take my other diagonal, which is 5 times 15, and I get 75. Oops, I forgot to write my x. So now I have 12x equals 75, so now I divide both sides by 12, and I get x equals, and I just take my calculator and go 75 divided by 12, and I get, 6.25. And so cross multiplication is very, very handy with proportional situations. Even when it's in a ratio form, you could rewrite it as a fraction, right? 5 over 8, 21 over x, and cross multiply that way, right? But you'll notice that if I'm cross multiplying that way in a fraction, it's the same as cross multiplying right as the ratio. I can do the same thing. I can take my x and my diagonal to my x and say, well, I have 5x, and make that equal to my other diagonal multiplied together, 21 times 8. Right? So even as a ratio, you can cross multiply. I can divide by 5s, and I get x is 33.6. So let's start using, unless it's a simple, oh, I'm just multiplying by 3. If it's simple like that, do that. Otherwise, let's practice with cross multiplication because it's a nice, accurate way of solving. All right, a train can travel 45 kilometers in 12 minutes. At this rate, how far can it travel in 2 hours? So let's write this as a rate. The train can go 45 kilometers in 12 minutes. We want to know how far, unknown, use a variable, it can go in 2 hours. Since I have minutes, let's write it in minutes. Okay. Well, this one, I can just multiply by 10, right? So don't use cross multiplication if it's that simple. I could cross multiply too. I could go 12x equals 45 times 120. I could get the big numbers, and I can then divide by 12, and I would get 450, right? But I do that when you can see, oh, I'm just multiplying by 10, so x is 450 kilometers. A 24-meter tree casts a 42-meter shadow. Okay, so we have this tree, and it casts a shadow on the ground, right? That's where the shadow is. So the shadow at a certain time of day is proportional with any object, right? Because the angle of the sun is the same for both. So if we had a building and it's also casting a shadow on the ground, then the shadow, the tree height, as compared to the length of the shadow, is equal to the building height as compared to the length of the shadow of that building. So we can create a proportion. So we know a 24-meter tree as compared to its shadow is equivalent to, I'm not sure how tall the building is, so we'll put x to a 147-meter shadow. Okay, so that is our proportion. So now we need to solve for x. This one might be a good one to use cross multiplication on. So just get a little extra space here. So I'm going to ignore the meters, ignore the word shadows and trees. Those ones just keep me organized, making sure my units all match up. I have them there, but now when I go to do the math cross multiplication, I'm going to take the x and multiply it by the 42. I'm going to make that equal to the 24 multiplied by the 147. Now I'm going to divide both sides by 42. And I'm going to get that x is 84 meters. We now know that is the height of the building. This is 84. 84 as compared to 147 is equivalent to 24 as compared to 42. They are in proportion. All right, our last question. On a map, 2.5 centimeters represents 400 kilometers. So I'm going to write this one in terms of a ratio. You can write it fraction-wise or you can write it ratio-wise. So this is map as compared to actual size. What distance would a 3.8 centimeter line represent? So we know this is the map as compared to the actual length in real life. I'm going to put an X. Now, remember, our units match up. Whatever my units are here, centimeters, kilometers, I need the same units, just like I did up here, right? The units have to match. Just like I did up here, the units had to match. I had hours there, I had to change to minutes. You cannot cross-multiply with mismatched units. All right. So here again, we can do a few things. I can say, well, how am I getting from 2.5 to 400? Whatever I'm doing, do the same to both. I could do it that way. I could even do it this way. How am I getting from 2.5 to 3.8? Well, whatever I'm doing there, I need to do here, right? That's one way. I could even cross multiply. I could take my 2.5 multiplied by x and make it equal to my 400 multiplied by 3.8. Divide both sides by 2.5. And get that x is 608 kilometers. right? Because that's the unit.